Welcome to Let Me Fix This. Enjoy the video.
You start by assembling and shaping data. Filter noise, normalize text, and split into training, validation, and test sets. Next, pick a transformer architecture and tokenizer. These choices determine capacity and token granularity. Once chosen, provision compute and define hyperparameters: batch size, learning rate schedule, weight decay. Set checkpoint frequency so you can monitor overfitting. Begin a short warm-up run to confirm pipeline integrity before full-scale training. That verifies data flow and model initialization are correct. You launch distributed training and use mixed precision to accelerate steps and reduce memory. Monitor core signals, training loss, validation loss, perplexity, and gradient norms so you spot divergence early. Make sure to save checkpoints and sample generations at intervals to assess qualitative behavior. If training becomes unstable, apply gradient clipping, increase batch size or lower the learning rate, and add dropout or weight decay. Once the model converges on validation metrics, schedule a longer evaluation pass to compare checkpoints and pick the best. You fine-tune for the target use case with a lower learning rate and monitor for catastrophic forgetting, using early stopping as needed. Once stable, optimize the model for inference. Quantize, prune, or distill to meet latency and memory targets, then containerize with batching and concurrency limits. Deploy behind a safety layer and logging. If outputs are wrong, inspect training data for bias or drift. Review sampling temperature and top K/top P settings, and examine logits and attention patterns to pinpoint root causes.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.